Alright folks, in the last video we discussed about a deep neural net model in which we were able to predict the fare of a cab in Chicago area within $14. That means the RMSE, root mean square error, was around $14, 14.835, around 14.84. So what we want is a lower RMSE, that means better prediction confidence, which means lower possibility of an error while predicting the fare. Now, what we are going to do is, in order to improve the performance, there is something known as feature engineering. Features means the columns, the predictors which affect the target column. In this case, the target column is fare. So what are my columns affecting the fare? And then how you can tweak the columns from a business perspective. This is where you would need a little bit of business understanding, data science, so that you can do a better feature engineering. Again, feature engineering is that science which can help improve the performance of the model if you take it the existing features or add more features so that you can change the prediction behavior of this model. So let's see how we will do feature engineering. Now, just a word of caution here. This video could be a little bit longer, so I wanted to break this video into two different parts. But if it is around 14-15 minutes, I'm gonna, have it as one single. Let's see how it turns out to be. But for now, let's understand a little bit business and see how feature engineering can help improve performance. Okay, so this data set is of Chicago. So what I did was went on to Google, search on Chicago latitude longitude, lat long, and you see that it says 41.8781 degrees north and 87.6298 degrees west. Don't get confused here. All I'm saying is just wanting to show you that lat long of Chicago is 41 degrees, and that was what my pickup latitude and drop off latitude, pickup longitude and drop off longitude showed. Doesn't mean anything more than that. So don't get confused. I'm not going to teach you geography here. Now, so a little bit of geography. Look at the Chicago map, and as a step, a possible step, I'm not saying this is the step, I'm saying this could be one of the steps of feature engineering. And feature engineering to me is more of an art, as well as a little bit of science, business involved for you to really improve the performance of the model. And there could be several thousand, hundreds ways to improve performance. So this is one of them. So I took the map of Chicago and then divided the maps into buckets. So I will show you one more time over here. This is the map of the Chicago area. So I had lines, buckets, vertical. So this is one bucket, 2, 3, 4, 5, 6, 7, 8, 9. In the code, I have used 5 buckets. And then in the horizontal, I am dividing into the same number of buckets. What I got is a cell. The reason I am doing this is because I'm not saying that I'm going to go to the lower street level detail and then I'm going to predict a street to a street. It's going to be a little bit challenging for me. And that is why my RMSA is so high, because I cannot predict from a street, because you may have to make a U-turn or whatever it is. So I'm not going to predict from a street to street, a block to block. I'm going to divide the entire Chicago map into buckets for a better prediction. So rather than seeing from a street level, I'm going to predict price from a bucket to another bucket. So and more the buckets, the bigger the data set, but accurate would be the more accurate would be the model. So what I mean is, instead of predicting from one individual dot to another individual dot, let's assume like this. I'm going to predict, let's say that somebody books a cab from this bucket to this bucket. I'm going to predict the price at the bucket level, cell level. This is one cell, this is another cell. This helps improve my model performance. So rather than predicting from here to this piece, I'm saying I'm predicting this cell to this cell, and that is why the RMSE would be lower. Think about it. You can pause the video, think about it, and read a little bit on the internet as well. There are very good articles out there. So all I'm doing is dividing it into cells, buckets, which are the horizontal and vertical buckets. So this is horizontal and vertical buckets forming cells. So this is, in principle, I'm doing it. Next is Euclidean distance. That means distance from here to here. I'm calculating the distance of the cell. This is one cell, right? One square is a cell. Think about it, pause the video, think about it, and then let's move on to do it. Now, here I have defined the buckets and buckets as 5. So 5 into 5, I'll show you the code as well. Now, please understand that the latitude and longitude, the first slide which I showed you today was for Chicago, 42. So I'm saying within 1 degree, 41.5 and 42.5 and 88 and 87, divide that bucket, make those cells, make those squares. Next, I am going to get the bucketized columns. So pick up latitude, pick up longitude, drop off latitude, drop off longitude, latitude buckets and longitude buckets. I'm going to divide. Please note that I'm going to have equal number of latitudes bucket and equal number of longitude buckets. Next, please understand that I have to calculate the Euclidean distance, and that is why I am doing a feature cross. Read about feature cross on the internet if you want to know more detail, but all here I'm doing is I'm crossing two columns together. In this case, I'm crossing, that means cross multiplying, pick up latitude and pick up longitude. So I'm getting all the buckets combination possible for pick up latitude and pick up longitude. It can be literally all the cells because you can pick it up from any cell and drop off to any cell. So this is drop latitude and drop longitude. If you look at it, I'm creating those massive columns of latitudes multiplied by longitudes. So it's n number of buckets. And then I'm going to do a pair. So I'm going to find out a pair in which I have, and in all the data set, all the possible combination of data set, I want to find out if there is a pair where I'm picking up from a cell A and dropping it off to cell B. I want to do all the pairs of the buckets. This is done to be able to make that data consumable. So think of this. I am getting the pickup latitude and longitude, drop off latitude and longitude, and multiplying it. That means crossing it, feature cross of two buckets and drop off buckets. And then again I'm pairing, finding out all the combinations where there was a pickup and drop off. Now there is a concept of wide columns and deep columns. Read about wide and deep columns on the internet, but wide columns are those columns which are sparsely populated. The number of columns or the cell values are minimum or less. It's known as sparsely populated wide columns, and deep columns means densely populated columns like pick up lat long, drop off lat long, and Euclidean. I'm going to calculate the Euclidean in a few minutes. But for now, understand the code. I'm going to show you how to run it and what you can expect. But for now, don't get too much into it. Just for now, run it And then once you get a little bit of confidence in feature engineering, you're going to get to the next level. I would strongly recommend, don't spend too much time in understanding the code yet. Do the code bisection and run the code one by one and see the results, but not now. Just understand what feature engineering is. Moving to the next thing, here I am defining a function which is add more features, and this is pickup lat, drop lat, pickup long, drop long, and then I'm finding the latitude difference and longitude difference so that I can create an Euclidean. If you remember from our mathematics days in the school, we had square root of lat difference square plus longitude difference square. That is my Euclidean distance. This distance is important because I want to find out how far those latitude and longitudes are. Please understand, if I can add one more feature to the existing data set, finding out how long the drive is. It may not be just dependent on miles, but I want to find out physically, irrespective of where the roads are, how far those points are, right? So that is why I'm creating Euclidean distance. So these are two sets of code. This was code number 1 and this was the code number 2. So let's start and run it. So from the Google Drive sheet, the Colab notebook, open this one, DIY4, and then import shutil. Please look at my previous video, and there I'm defining what is script util. Again the same, out dr yellow cap, buckets, remember the n buckets, the number of buckets, I am doing it as 5, and I'm just defining a placeholder for input features, and all I'm saying is that the feature column is a numeric column, which is pickup line, lot, longitude, latitude, and then difference of latitude and longitude and Euclidean distance. This is just a placeholder. Next, this is what we discussed. So I'm defining what is plon. See, pickup lon, what is plon, plat, drop off lon, drop lat, and then this was just for my debugging. And then lat buckets, long buckets, I'm defining what the buckets range are, and then I'm bucketizing those columns. Next, I'm doing a feature cross and defining wide and deep columns. Wide are sparse columns and deep are the densely populated columns. All I'm doing is going to run this, and that's it. Don't think too much at this point in time. Just run it, and then once you are a little bit confident, then you can break this code apart. And then I'm using the feature engineering I'm using the same columns as what we did without the feature engineering, and I'm creating this add more features which I just showed you to create the Euclidean distance. This add more feature is to create an Euclidean distance. That's it. And I'm going to define a data frame, and I'm calling it as feda-df features, and the same trip miles, seconds, pickup lat, lot. There is no change from the previous one. That's it. So in the next step, we are going to learn, in the next video, in the following video, we are going to learn how we do this feature engineering. Again, the section is improving model accuracy with feature engineering. We want to improve on RMSE on dataset, which was 14.84, without doing any feature engineering. And now we are doing feature engineering here to improve the model performance. So first, with what we did, pick up lat long, and we created feature crosses to find out the buckets, and then we defined wide and deep columns, and then we created a function to create Euclidean distance. That's it. Okay, and then we have defined a data frame which is exactly similar to the previous data frame, and all we have done here is add more functions. We called this add more functions, which is here, add more features, I'm sorry, add more features to add features about on this. So if you look at it, this fdoft features has pickup lat, long diff, lat diff, and Euclidean. These are some features which I added to the dataset. Okay. In the next video, we're going to see how you can get a better root mean square error.